procedural programming, functions and data are separate. They do not model real-world entities efficiently. So we typically write a bunch of functions that operate on data, and the issue is that the data and functions that use it are kept apart. This makes it hard to think about the program in terms of real-world entities. So real-world objects combine state and behavior. In real world, every object has two main aspects: state and behavior. For example, think about a person. A person's state might include its height, age and mood, things that basically describe them. The behavior includes actions like running, sleeping or speaking. Both the aspects belong to the same individual, so you can't separate them. But in procedural programming, we treat them as if they are completely independent, but that's not how the real world works. Another big problem with procedural programming is global data. When the data is accessible by many functions, any of them can change it, sometimes maybe unintentionally. For example, if you have a global variable, for example for storing the total number of available cars, one function might update it correctly, but another might accidentally reset it or maybe corrupt it. So this makes debugging and maintenance very much difficult because it is harder to track who changed what and when. Finally, poor scalability. That's adding new data means modifying many functions. The procedural code doesn't basically scale well. Let's say our car structure gets a new attribute, for example, GPS enabled flag. Now every function that deals with car need to be modified to handle this new change, this new property of GPS enabled. So as the programs grow, this becomes very unmanageable and error prone. So to solve these problems, object-oriented programming was introduced. Instead of separating the functions and data, OOP basically combines them inside objects. Each object keeps its own state and defines its own behaviors. Now that we have seen the drawbacks of procedural programming, let's look at why object-oriented programming becomes so important. It reduces effort and complexity. Number one, for example, in large procedural systems, adding new features or fixing bugs can be time-consuming and error-prone because of the tight coupling between the functions and data. So OOP reduces this by organizing code around the objects that encapsulate their own data and logic. So this makes the system easier to understand and modify and extend. Next is faster adaptation to change. Business environments basically evolve. New requirements, new regulations or new customer needs arise all of the time. So with OOP, systems can adapt more easily because objects are modular and they are self-contained. So you can update one class and then replace it entirely without rewriting everything else. So the main goals of OOP are to make the software development more efficient, flexible and reliable.